Please don't break anything. Alright guys, it's about that time. Have a nice week. Make sure you move the desk back. It was solved when you took it.
No, I solved it. I actually solved it.
No, when you took it solved and you
I
pretended
can solve it. I'll show you. I figured it out.
I've heard that it's not too hard.
Yeah, it's not too hard. I only had to watch a video for the top face because I got all.
Oh,
the
really?
sides. Yeah.
Like the first time?
Yeah, I got all the other sides except for the top gray face, and that's the only part I have to watch video for. Alright, so
bullshit, bro. I had it with you. What? You can sit down and sit there. No. I got half of it done, but I didn't do the AP costume. I slept. Twice. You caught me the first time. Bro, when he explains stuff, he does it so quickly, it's so confusing. He's like, check this out, check this out. He caught me the first time I was asleep, just trying to go back to sleep.
The tan
Because it's like I started this over the weekend. I didn't love school. I locked in. Hey, what is that?
I don't even know what hours.
I was at an orthodontist appointment, and they gave me a Z. Well, I got a C. How?
She was my
I got
fourth
6 out of 8 first 10 years. And these are because I don't put in my syllabus.
If you're not gonna do it.
I'm too lazy. Well, you remember how to do significant units? No.
Oh, you actually know that as first. Yeah, that's very cute. I was getting the cat from like the newsies today with like a whole black French coat.
It's the most fun class of the day.
Finally, we got it.
It's better than APCSA. I had to write like a 500-word essay in that. Yes. It's over women in computer science. I've done the same assignment the past 3 years.
Sometimes like you just
What? You scared me? I've done it 3 years in a row now.
Why, do you not do good on it?
No, I thought I had the website, but I thought I did perfect on it, and this was a 13-hour quiz.
A different because he doesn't want to.
I wasn't trying to trick you.
And I was running late.
I don't-
That's so much.
I've had him for the last 3 years. He's the only computer science teacher in the school.
Yeah, we should
It'll be
I signed up for
He's the goat. So like,
University of Mexico.
Sorry.
Alan.
It is Albuquerque.
Jack. All right, good morning, guys. First thing we need to do is finish up the notes we started last class. So I need you to get 15 out from your binder.
Do you have an extra copy of 15? They're not in.
Yes, I'll get you one. Okay. All right, so last class we did our quiz. Just remember, you are welcome to come and see during advisory. In fact, you're encouraged to come and see those, but you do have to wait till they're all made up. And my B-Day classes don't even take it until tomorrow, so you'll need to be a little patient there. If you did not take it last week with us, then I should have signed you up for prime time. If not, please make sure you sign yourself up. Okay, so after the quiz, we started talking about what the second unit's going to look like. And the second unit is, again, pretty computational, and meaning that, like, we were going to have questions that have 4, 5, 6 steps. Algebra, 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 algebra. That's going to be the majority of it before we can start to get into more interesting stuff. But I can't stress enough how important this unit is going to be for the whole semester. Because we're going to talk about how to find derivatives by hand, things like power rule, product rule, quotient rule, chain rule, and then not only will we use those the rest of the semester, but then next semester when we get into integration, integration is actually the opposite or the inverse of derivatives. So it actually helps with that as well. So this is one of those topics that will eventually stick with you, but of course if it sticks early, then it helps your grade out that much more. So the 30-second review of what we talked about last class, just a quick little refresher here. Okay, we talked about how to find the slope of a line if you're talking about something linear. So if it's in point slope or mx plus b format, a linear line always has the same slope, so we try to identify that just by looking at the equation. And then we start talking about in calculus, the slope can vary depending on what x is, because we start talking about stuff with curvature. So we have this thing called the derivative, which basically means slope. It's basically a formula to tell you the slope at any given x value. So if you want to know the slope when x is 0, you plug 0 into the derivative, and then you know the slope at time 0. You want to know the slope at x equals 1, you plug -1 into the derivative, and you have the slope at -1. I showed you that the definition of a derivative really just comes from taking two generic points into the slope formula. We looked at one where we found the derivative by hand, but we won't have to do that anymore after this question. So we're going to start to get into some of the shortcuts that makes it where we don't have to do this 5,000 times a semester. But we did one by the definition, and we got the derivative in question 3. We found the derivative at x equals 1 in question 4, and then we pieced the derivative at x equals 1 with the point and came up with something called the equation of a tangent line. With these three, I really tried to emphasize to you that very slight wording changes what your answer should look like. Derivative is going to be what we call the derivative, basically the formula for slope. Slope at a certain point means you just plug that x value into the slope. And then that's kind of a representation of what the tangent line looks like. but sometimes you're explicitly asked what is the equation of the tangent line. So point slope, the slope comes from derivative and the point comes from the function. So again, slope tends to imply you're talking about linear functions, whereas derivative means you're talking about anything. But slope and derivative basically mean the same thing. For your purposes, you can just think of derivative as slope. Okay, we looked at that in the calculator. We talked about at some points you're going to have to memorize the standard definition in the alternate form. So I was going to have you practice some of these on Khan Academy today, but I'm going to postpone that. But we did a couple of these practice questions together. And I think I asked you guys to do question 10, but I don't think we went over question 10. Is that correct? That's not correct? I did not ask you to try question 10? Okay, that's fine. This makes a good one to do a quick little review on. So even though they won't expect you to find the derivative by the definition, I'm about to show you some shortcuts on one of the handouts you picked up today. Also, just a heads up, some of those handouts you picked up today will not be yours to keep. The book pages, I'm going to ask for those back at the end of class. Those are just yours to use during class. I have them posted on the website if you need to finish up some for homework. Okay, but when I look at this, I have these two memorized, whereas you would need to be kind of glancing up here to think about which one of these two it fits to the most. And because all of these say as h approaches 0, to me that means that this is going to fit the standard form of the derivative. So in your head, what you would have to do when you see one of these on your next test is you're going to have to think about, okay, this is what the standard form is supposed to look like. All of these have the limit as h approaches 0, so that doesn't help me narrow it down at all, unfortunately. This is supposed to be the function with x plus h plugged into it. So that could be any of those, but notice sometimes they're using x and sometimes they're actually plugging something in for x. This is supposed to be just the function. So again, we don't really know. Something here is going to be the function. It could be the function with x's. It's still in terms of x's, and it could be the function with a value plugged in. And then it's supposed to all be over h. Well, all of these are over h, so that doesn't help narrow it down at all. So for this question, I would say that it looks like they are trying to plug in e. They're trying to find the actually, they gave me this up here. That would make it a lot easier. We're trying to find the derivative at e. Remember, this one little tick mark changes from talking about the function to the derivative. Very big difference. For e to the x. So over here, this might be the function, and so you might expect this to say e to the x, but you can tell they're plugging something into that. They're either plugging in 1 for x or e for x. This is a 1, this is a e. E1. So over here, we need to be doing the same thing, consistent. This is supposed to be the function with x plus h plugged in. So if here's the function, and instead of x, I put an x plus h, it could look like this. So that could look like these two, except there's a problem here. Can anybody figure out what is inconsistent about part or choice C? Good, they're plugging in e for x here and not plugging in e for x there. So if you're going to plug in e for x, that's great, but you can't do it inconsistently. It's either all the time or not at all. Okay, over here, if this was correct, they left this at x, then this function would need to be e to the x. So that doesn't make sense. They're missing this x. And then what about between a and b? Which one of these? They're exactly the same thing except for this part. Which one of these parts looks like the function e to the x, but they must be plugging e into it? So it must be b. So again, this just takes practice. You just have to practice 10 or 20 of these before you start to pick up on the pattern recognition. So eventually, probably next class, you'll need to memorize these two so that you can see which one it looks more like, and then through process of elimination, based on these hints, you can narrow it down. This is one of those topics that, you know, if you're terrible at this, it doesn't really hold you back at all at the beginning of the year. So we do review it again before your AP exam, because even if you know it now, 6 months from now, you get rusty on it. Okay, the parts we did not talk about last class, to finish up these notes, because my computer was throwing a fit last time. Is we need to talk about kind of when a derivative makes sense and when it doesn't make sense. So, looking at this graph over here, what would you say the slope is at x equals 4 if you just had to estimate and guess? No wrong answers.
0.
Okay, you could guess 0. It does look kind of like 0, but 0 is not the answer. Other guesses? Okay, well this, if anything, I would say this is negative, not positive. So I wouldn't say half, maybe negative a half. But notice, there's no point at x equals 4. So if my graph doesn't even exist at x equals 4, then his slope does not exist either. Okay, what about at x equals 6? What would you say the slope is there? Yeah, it doesn't make sense, right? This does not exist. At x equals 6, like, we don't have a temporary slope here. I mean, I guess it was doing this, but then it's jumping to this. So what both of these things have in common, well, other than they both don't exist, is something else that we have talked about this year. Very good. They are discontinuous. So the first requirement for you to be able to take a derivative is it has to be continuous. If a function is not continuous at a certain point, you cannot take the derivative at a certain point. So for a function to be differentiable at x equals a, it must be continuous there, which of course we now know from our quiz on Friday. That means that there is a point at x equals a, there's a limit as x approaches a, and the point has to be in the same spot as the limit. Okay, another way that you could not take a derivative, well, think about just regular old equations. If I wanted to sketch something that has an undefined slope, what does an undefined slope look like? Very good. So if we have a graph that is temporarily vertical, again, derivative, just think of it as slope. If the slope doesn't exist, the derivative doesn't exist. So it must, we can say, not be vertical. And then finally, the last one, part 3, a good visual for this is it must not have any cusp. Cusp are like sharp turns, but more important mathematically, because if you're ever asked, does this have a derivative, or prove it has a derivative, or prove it doesn't have a derivative or something, the problem with the cusp is that at that instant, the slope changes radically. It goes from something to something else at an instant, and you can't do that. So we need the derivative from the left has to equal the derivative from the right. So if it's approaching 4 from the left and it's approaching, I'm sorry, a slope of 4 from the left and a slope of 4 from the right, then that derivative is going to make sense. Okay, because it does not make sense to be take a derivative without it being continuous, we also have this thing in mathematics. This isn't real important right now, but if something is differentiable, we can assume it's also continuous. However, I can tell you on FRQs, there are some that are set up where the scoring guides say, you have to say this. So like you might see an FRQ and it says f of x is differentiable. You may not need this, but sometimes you do need this. I would just instantly write down, if it's differentiable, that implies it is continuous. That's a good habit to get in, just putting that down, because when you need it, sometimes that might get you a point, and if you didn't need it, it doesn't hurt anything. But it's not possible to be differentiable and not continuous. So for a derivative to exist at a point, again, it's got to be continuous there, which implies 3 things. It can't be a vertical line, because then it doesn't have a slope, so it doesn't have a derivative. And you can't see a cusp. The cusp is the sharp turns, and the way we would describe that algebraically. The derivative from the left is not the same as the derivative from the right. The slope is changing. Okay, so for what x value is above, is the function continuous but not differentiable? Is there any places where this is continuous but not differentiable? Sorry? Very good. At 8, you see how this is a sharp turn like this? If you have a visual and you're interested in if it's, you can take the derivative. Just look for those sharp turns. Your slope can't change that quickly. Bless you. Okay, and then to finish up these notes, using this picture over here, what would you say the slope is at point A? One more time. Okay, does not exist or undefined. So a derivative does not exist when the slope does not exist. So you could not take the derivative at x equals a. You can take the derivative, but when you plug in a, you get something divided by 0, which doesn't return a value. Okay, so our next handout, this is where I'm going to give you the stuff that we need to memorize over the course of the semester. But I'd say all of this, most of this. Okay, other than the practice questions at the end, this is just stuff that we need to memorize. So the idea of this is, these are the things we're going to use so often that we don't want to have to use the definition. Technically, the definition of a derivative, which we talked about in your notes, is a long way to find the derivative, and you could do that. Okay, but first, let's just go ahead and talk about, let's just go through these. So there's the constant rule. So if I wanted to know the derivative of the function 6, well, you could think about, again, you want to memorize it, but I'm just trying to show you to help it make sense. Here's the function y equals 6. What is the slope of that line? One more time. Slope is not 1. 1 looks like that. The slope is 0. So what's that mean the derivative is? 0. So that property just says anytime you take the derivative of a constant, it is 0. Because remember, derivative is like slope. A constant doesn't change. It's why it's called a constant. It doesn't vary like a variable. It's constant. So the derivative of -2 is a constant, so the derivative of that would be 0. Again, you could also think of it as y equals -2 as a horizontal line which has a slope of 0. Slope is derivative. Okay, power rule. This is going to be the one you use the most by far. This is what the property says. It says if you want to take, when I'm reading this, this is saying if you take the derivative with respect to x, and we're only doing with respect to x for a while here, of x to the n, it becomes n times x to the n minus 1. So that's what the property says, and I think that'll make more sense. But most people don't phrase it this way. Most people see it as the exponent comes down out front, so bring the 2 down. And then notice the exponent becomes 1 less than what the exponent was. So if it was a 2, now it's a 1. So in our notes last class, I used x squared as an example, and I told you to trust me that the derivative was 2x. That's how I knew it was 2x. I was applying this thing called the power rule. So here's another one. Bring the power down, lower the power by 1. The derivative of 8 to the x is 8x to the 7th. If you want to know the derivative of x to the 5th, bring the power down, lower the power by 1, 5x to the 4th. What would be the derivative of x to the 1000th?
1000x, 999.
Power rule is one of the easiest things in calculus. Bring the power down, lower the power by 1. Now again, keep in mind that we want to totally program our brain with this over this semester, because next semester we're going to be undoing these. And you might start with this and end with that. Start with this and end with that. We're going to be going the opposite direction next semester. Now remember, I just found 4 derivatives here. Remember what these things are supposed to do. These are like formulas. If I want to know the slope of x squared when x is 5, I just plug 5 into its derivative. If I want to know how fast or slow the graph of x to the 1000th is at x equals 0, I could plug 0 into its derivative, and I know how fast that graph is rising at that time. Derivative is like a formula to tell you slope. It generally is going to have x's in it, and so whatever x value you want to know the slope of, that's the value you would plug in. Okay, there's something called constant multiple rule. So that just means that if you have a number out front like this, you can really work this 2 ways. Obviously, I don't expect you to work it 2 ways all the time, but let's go ahead and talk about both ways for our notes here. You can either bring the constant out front. If there's a constant, you can deal with it after the derivative. Then you can take the derivative of this and multiply it by 2. Or, and honestly, that's what you usually want to do. You're going to think that this way is easier, but it's just the example. Or you could just do power rule. You could bring the power down and then lower the power by 1. But notice these 2 things are the same. So if you have a constant like 2, you probably just want to bring it out and multiply your derivative by 2. It's going to make things simpler. Okay, over here, I could bring the 3 out front and then take the derivative of x to the 8th. So bring the power down, lower the power by 1. Or I guess technically, if it was just this, you could just do power rule. Bring the power down if there's already something there. If there's already something there, when you bring the power down, you multiply them together and then lower the power by 1. Okay, so feel free to do the 1/2 later. Do this and multiply it by 1/2. Feel free to bring the 4 out front, take the derivative, multiply your derivative by 4. So, same thing we did with limits. If it was a limit of 2 times f of x, you could just double the limit of f of x. If you've got the derivative of 2 times something, it's going to be 2 times whatever the derivative was. Just worry about the constant after the fact. Okay, also similar to limits is adding and subtracting works the way you would expect it to. Multiplying and dividing, not so much. So we have something called the product rule for when it's multiplying, and something called the quotient rule for when we're dividing. Those are for another day. But adding and subtracting work out the way people expect them to. You just take the derivative of each one separately. If it said plus in the middle, you add them. If it had said minus in the middle, you subtract them. So to find this guy's derivative, I could do power rule, bring the power down, lower the power by 1. Do this power rule, bring the power down, lower the power by 1. And then since there's a plus sign in between, slap a plus sign in between. Derivatives, you can just do one term at a time. Okay, so to make sure that this stuff is clicking okay, what is the first part of this derivative? Okay, 12x squared. And then somebody else, what do you think the derivative of this would be? 7, good. You can bring the power down, it's just a 1, so it doesn't change anything. And then when you lowered the power by 1, it leaves it x to the 0. X to the 0 is like 1. Okay, you try this one. Just go ahead and write down what you think it is. If it's wrong, you can correct it. Okay, and honestly, that's all the time that you should need since you get to do these in parts. Power rule, power rule, if there's 4 terms, you might need to do the power rule 4 times. But that's what you'd end up with. Everybody okay with that? Okay. So some of the other stuff, so I guess you do have to memorize the power rule, but once you use it 20 times, it's one of those things that's really hard to forget. So I'm not too worried about that. But on the next page, we've got some stuff that we use a lot that we also need to memorize. So the first is going to be the sine and cosine functions. We actually do memorize the derivative to all 6 trig functions: sine, cosine, tangent, secant, cosecant, and cotangent. But for today, we're just talking about sine and cosine. So the derivative of cosine is negative sine, and the derivative of sine is cosine. You need to be careful there because one of them becomes negative and one of them does not become negative. If you oversimplify that rule, sometimes you're going to forget to make it negative, or you're going to make it negative when it's not. Derivative of cosine is negative sine. The derivative of sine is cosine. And so you might need to take the derivative of something like this, but of course we can just do these one at a time. If you have this memorized and that memorized, then you can take the derivative of cosine x minus sine x. And if we throw numbers in front, again, that's just the constant multiples. This is going to be 3 times bigger than that. This is going to be negative 4 times bigger than that. Does everybody see why I changed this to a plus? Okay. So you got to memorize the derivative of sine is cosine, but the derivative of cosine is negative sine. Okay, the next one's one of the easiest ones we do. E to the x. E to the x is a special one because it's one of like 2 or 3 functions that is his own derivative. E to the x grows at the rate of e to the x. So the derivative of e to the x is e to the x. You want it to be 5 times bigger, the slope's going to be 5 times bigger. Bring the 2 out if you want, bring the 5 out if you want, but derivative of e to the x is e to the x. Derivative of e to the x is e to the x. Nothing else that you can do with that. Now again, if you are really, really interested in why is the derivative e to the x, you can plug e to the x into the definition of the derivative, do some algebra to simplify, take the limit as h approaches 0, and you see that you get what you started with. But that would be proving it. You don't have to prove it in this course. Okay, so derivative e to the x is e to the x. We've got derivative of natural logs is 1 over x. The derivative of natural log is 1 over x. So if that's the question, just change it to 1 over x. If there's a 2 there, it's just going to be twice as big. And I would like you to try this box because it throws a few of the things we've talked about together. Try to take the derivative of this whole thing and see what you come up with. Okay, so you should have said derivative of this part would be 2 times 1 over x, or just 2 over x if you'd rather. The derivative of e to the x is e to the x. This one's times -4. And for this last part, what did you put? Very good. -8 sine x. Derivative of cosine is negative sine, and that's just 8 times bigger. Okay, and looks like we've got one more. So if you wanted to take the log, this one's very uncommon. So if it's not natural log, it comes up all the time. In calculus, 99% of the time when we talk about logarithms, it's natural logs. But if it's a log of a different base, it kind of fits this pattern here. So it's almost like if you're taking the log of x, you still get a over x. The log of x is still going to be over x. But we also need to divide by the natural log of the base. Now technically you have to do that with natural log also, but since the base is e, dividing by the natural log of b is really just dividing by 1 and doesn't change anything. So this could be, 1 over x natural log of 8. And then let's see if you can figure these out. What's the derivative of log base e of x? Very good. That's just the same thing as natural log, so that's one that we will memorize. And then this guy is basically the same. We're doing the log of x, so we're going to need a 1 over x. But if the base is not e, you need a natural, what's a natural log at the base? Yeah. Times the natural log of 9. I would not worry about memorizing this one at this point. We don't use these very much. Okay, so now we've got a few under our belt here. We know what the power rule is. You see, it's pretty easy to apply. We've got a few that we have memorized, so we can do quickly. As soon as you see derivative of natural log, or e to the x, or sine or cosine, those are ones that we need to know quickly so we can do quick little substitutions. But here's where a lot of your struggle is going to be when you get on to practicing these questions. I know you can memorize those couple, and I know you can do the power rule. That's not hard arithmetic. But some of your book questions are going to be like these, so we need to talk about how to approach these. So first off, notice this is asking me for derivative. And to find the derivative of this, you cannot do power rule yet. Power rule works when you have a variable to some exponent. This is not like that. So a lot of times in calculus, before you do any calculus, you need to rewrite the problem, either with exponent rules or fraction steps, or maybe changing square roots into an exponent of a half. You need it to look a certain way, you need it to look a certain format before you can do power rule. Now that I have rewritten it to match the power rule, I can bring the power down and lower the power by 1. And then the last thing you need to make a habit out of doing, which unfortunately is a pain sometimes, but negative exponents in math are typically considered unsimplified. So how can I make this positive? Okay, just move it to the bottom. An exponent of negative 3 in the numerator is the same thing as an exponent of positive 3 in the denominator. So the calculus that I did there was just a power rule. But before I could do the calculus, I can't just do, it doesn't make sense to do the power rule of the numerator and power rule of the denominator. It doesn't work that way. Okay, on the next one, same thing. I'd like to do the power rule, but this is not set up the right way. So the 5th root of x is the same thing as x to the 1/5. And as soon as you make that exponent change, now power rule is simple to apply. Bring the power down, lower the power by 1, and then if you have a negative exponent, you need to practice moving it to the other side of the fraction and making it a positive exponent. Okay, and then last example in this little set, same thing. This doesn't look like power rule and it doesn't look like anything I have memorized, so I'm limited on options. But this simplifies. Anytime you can do calculus, or I'm sorry, algebra before calculus, you probably need to. Square root of x is like x to the 1/2. When you divide things with the same base, these both have a base of x. What are you supposed to do with the exponents? You subtract them. It's why x to the 5th divided by x to the 4th is just x. I know you think about 4 of these canceling out 4 of those, but it's really like you're subtracting the exponents. So 1/2 minus 1 is negative 1/2. And now that it looks the correct way, I can think about derivative. Bring the power down, lower the power by 1, and if you have a negative exponent, move it to the other side of the fraction to make it a positive exponent. You cannot take the derivative at the start there until you rewrite it with exponent rules. Okay, another question type that's going to be come up pretty often is horizontal tangent lines. So we talked about tangent lines last time, or kind of a visual for the derivative at an instant. And we know horizontal lines have a slope of 0. What you need to understand is that this is going to come up a lot in this class because horizontal tangent lines are usually a real-world example of something interesting going on. So imagine this as a graph where you are away from home for a given time. So you were at home and then you left, and this is your distance graph. As time goes on, how far away are you from home? Okay, so where do you think we have a slope of 0 in this question? Okay, I agree. At x equals 3, it looks like it's temporarily a slope of 0. Somebody else, give me another. One more time. Okay, I heard 1. And somebody else? 5. And anything else? It's kind of close here, but probably not. But do you see how those are 0 at that instant? when the slope is 0, the derivative is 0. So when you were asked, if we skip a question for a second, when you were asked to find horizontal tangent lines, you should be thinking, where is the slope 0, and what's another way to say slope? What's a calculus way to say slope? Derivative. So when you're asked to find horizontal tangent lines, you're going to set the derivative equal to 0 and solve. Now, if this is a real question, and this represents distance, what do you think is going on when the slope is 0? Right, he's pausing for a second there, right? Now when you say stopping, that kind of refers to something else. During this time and this time, what's going on? You're moving, yes, it's closer. I'm looking for a word that starts with S. Your speed, good. So you don't have to know this today, but soon we'll be talking about the derivative of position gives you velocity. So when your slope is 0, that means your derivative is 0, which means at that instant your speed is 0. So derivative, one application of derivative, is we can take position functions, take their derivative, and all of a sudden we have a velocity function. But what does it mean in the context of this problem? This is when the person is at rest. So I'm just wanting you to think about the speed. The slope of position is speed. Then it turns out the derivative of speed gives you something else. Okay, and so then to practice this a few times, if the direction said find the horizontal tangent lines or determine where they have them or if they have them, here's just 3 questions we can do. So I'll call this number 1. So horizontal tangent lines, this is when the slope or derivative is 0. So you're going to have to take the derivative. It's either going to be power rule today or one of those couple I told you to memorize. And then if you want to know where it's horizontal, then you want to know when does the derivative equal 0. Set it equal to 0. Start solving. And what happens here? Okay, it's imaginary, which is fine sometimes, but imaginary lines or imaginary numbers are not going to show up on our graph. So the only times that the derivative equals 0 is imaginary numbers, which means this is going to have no horizontal tangent lines. So if you wanted to take a second and graph that in your calculator, you would see that at no time is that graph ever horizontal, not even for an instant. Okay, y'all tell me in question 2, what do you think the derivative of this function is? The derivative of x would be 1. The derivative of 4e to the x would be 4 times the derivative of e to the x, which is e to the x. You want to know where its horizontal tangent lines. You could try to set it equal to 0 and solve. So, of course, the solve could be 2 steps. It could be 10 steps, I guess. But the calculus part is understanding horizontal tangent lines is wanting to know when the first derivative is 0. If I switch these two, I would solve this by doing switching it from exponential to logarithmic, personally. And then you're going to be tempted to say that x could be the natural log of negative 1/4, but there's something wrong with that. Right, you can't take the log of 0 and you can't take the log of a negative. So once again, this guy also has no horizontal tangent lines. That graph is always going up or always going down. It never switches directions. Okay, and then of course your favorite, the trig one. So to take this guy's derivative, I could do power rule for the first term, and then the second term I have to know the derivative of cosine x is negative sine x. So sometimes that's all you need to do. You got to pay attention to the directions. But if it doesn't want the derivative, it wants to know where's their horizontal tangent lines. You have to know horizontal tangent lines occur when the slope is 0, aka when the derivative is 0. Then you could subtract this and divide that. And since this has 0 to 2 pi, what values of sine give you square root of 3 over 2? Okay, pi over 3 is 1. There's one more. Very good. Also 2 pi over 3. So again, I can't promise you that the solving is going to be easy. It could still be unit circle. It could be logarithms. It could be imaginary numbers. But you have to know horizontal tangent lines, the process. Set the derivative equal to 0. Okay. If I was you, I'd probably keep that guy out. It would be nice to refer to. But you will need your own piece of paper for number 17. So if you go ahead, you can see I said just start it. We're not going to try to finish it. You're not going to have to finish this one for homework. You can see it's a lot of questions. But get out a blank piece of paper. Go ahead and copy the assignment down to the top of the paper. Again, please do not write on the book pages. You picked up 3 book pages. 2 of them have the questions on there, and one of them is the odd solutions for you to check.
Mr. Johnson, can I turn these in from when I was absent? Is the quiz review number 13 or 14? Actually, I can still find it. Is it in the bucket?
Sorry, I don't know.
No shit, I can just go look.
Yeah, the quiz review was 13. Okay, just copy down the assignment. Again, please don't write on the book pages. I'm going to take those back from you. Remember, this is why I said you didn't have to check out a book, because we only do 5 to 10 book assignments the whole year anyway. If you change your mind about checking out a book, I can do that for you. But as I said, I have the book pages on the website. And in class, I've got So copy down the assignment, try the first question or 2. Honestly, a lot of these first questions can be very, very quick. I just did the first 10 in my head in about 30 seconds. So. just another minute or so, and then I will verbalize the first several answers. Oh, I guess while it's up here, do y'all understand the daily meme now?
Yeah.
The top part's the definition of a derivative, and this also means derivative. So no one likes to work with this, everyone likes to work with that. It's just a much nicer way to look at that. Okay, so pause what you're doing for just a second and let's make sure your first answers are correct. I'm going to just rattle these off. Number 3, the derivative of 12 would be 0. The derivative of any constant is 0. Question 6, you need to do the power rule. That would be 12x to the 11th. Number 9 would be the power rule after you change the root to an exponent. So that would be 1 over 5x to the 4th. Number 12. Number 12 is actually an interesting one. What did you get for an answer on 12? Do you notice how 12 is in mx plus b format? And the slope is 6. Slope just means derivative. It's the same thing. It's just that in calculus we don't always deal with mx plus b. But if it was mx plus b, then sure, then that is your derivative. Okay, so 12 would be 6 because you could do the power rule with 6x, and the derivative of 3 is 0 because the derivative of any constant is 0. All right, 15, you need to do the power rule twice. You would get 2x plus 12x squared. Number 18, you got to do the power rule twice and know that the constant is 0. So 18 would be 6x squared plus 12x. And then the derivative of -1 is 0 because the derivative of the constant is always 0. And then 21, you would get 2x plus 1/2 sine x. Everybody okay with that one too? And then same idea for 24. The derivative on 24 would be 3/4 e to the x minus 2 sine x. Any of those you need me to repeat, or any of those you want me to try to be more detailed on? Okay. So there's already a handful of questions where if you know power rule and you have a couple of those things memorized, you can kind of hit the ground running. Now again, question like number 9, I want to do the next question with you. I want to do 27 with you to make sure you understand the directions. But it's kind of like what you did with question 9. You should not just be winging it. You've got to make it look a certain way before you can do the power rule. So that's what they are specifically asking you to think about on question, which one do you do? 25, 26, or 27? 27. Okay, so they're giving you a question in 27. Y is 6 over 5x cubed. This is not in a good shape. This is not in a format ready to take the derivative. So if I ask you to take the derivative, which is the second step, the first thing you need to do is rewrite this. So 5 to the third, 5 times 5 times 5 is 125. And then x to the third is x to the third. But I can't do the power rule if x is in the denominator. I know it would be nice if it worked that way, but it doesn't. You have to rewrite this. You need to bring this up. So if it goes from the denominator to the numerator, the sign on the exponent is going to change. That's the rewrite step. The second step is differentiate, which means take the derivative of. Now that it looks like this, we can bring the power down, lower the power by 1, and then the last step wants you to simplify. So I don't think 18 over 125 simplifies. It does not. But x to the negative 4th, we could move it back to the denominator. Negative exponents are considered unsimplified. So really, that's what they're wanting you to do. But instead of saying take the derivative and hope that you think of those things, it's pushing you in the right direction. Before you take the derivative, you need to rewrite it. It needs to look a certain way. Once you take the derivative, make sure you have it simplified. Make sure you have positive exponents. Everybody okay with that? Okay, I will give you a few minutes here to try a few more. So there's 27. 30 is the same type of questions with the same directions. 33 wants you to take the derivative, but then also plug in the point. Same with 36. Okay, yeah. So what I'll do is I'll give you about 5 minutes. So just get a few questions done, and then we'll reevaluate.
Mr. Johnson,
Yes, sir.
could we see the problems again, what we're doing?
Yeah.
On 3,
What's up?
we still have an H? Do we just like ignore that?
Well, you also need this. The limit is h approaches 0. So you get to plug in 0 for h at the very, very end.
Okay, cool.
I got lawns to mow after.
The class recording, we went over all that part together. So
Oh,
it's fine for you to try it,
I've
but
just been like working out in the morning and then like doing my homework and then going to school and then practicing the lawns. But it sucks because I'm about to run out of work because like the grass is, it's all about what you do. Might do like moving or
Power washing.
yeah, I could power wash. I would power wash.
or you could just have more time for your homework.
Yeah, but I do need to make some money. Trying to invest.
And what?
In my Roth IRA. Is that smart?
Probably, but
You know what I did?
yeah, I have a Roth. All right.
You have one?
No,
Oh.
of course.
You watch any of the football games?
I didn't watch it live, but I was watching the score on the Razorback game at the end.
Oh yeah, that was a good one. Well, not a good one, actually.
Oh, I think it was good.
That we lost?
That, not that you lost, but that's way better than they would have done last year.
Yeah, definitely.
I mean, they've already shown a lot of improvement, so by the end of the year, they would have won a game like that, I think. They wouldn't have so many mistakes.
Yeah. Oh yeah, we definitely did good, but you know we were up 21-7 first half, and I just awful let them come back from that.
Yeah. It's part of being a good team, though, is
Right.
not quit.
Did you watch any of the Fayetteville games?
I didn't. Or I think you might have seen some highlights.
Yeah. If you're gonna watch any of the games this year, I'd come to the one next week. We play a really good team.
Yeah.
And
is
here
that-
at home, or watch it online. We play Texas High School.
Bishop Sycamore. Okay, it's been 5 minutes here, so is there a question or two I can help with here? Any of these? Yeah, what you got? 36. Okay, 36 says you've got a function g. That's okay, y'all have it on your page. Okay, and they say find the slope of the graph at the given point, and then use the derivative feature of your graphing utility to confirm your results. Okay, so first off, before you can worry about the derivative at the point, you need to find the derivative. This is in terms of t instead of x's, but the derivatives still work. So the derivative of -2 cosine t would be what? Okay, 2 sine t, and the derivative of 5 would be 0, which of course we don't have to put plus 0. Now, once you know the derivative, again, this is like a formula that will tell you the slope at any given time you want. For this particular question, I want to know the time at pi. This is a point. This tells me where it is. It has nothing to do with the slope or the derivative. So if I plug pi into this, the derivative at that time is 2 times the sine of pi, and the sine of pi is so the derivative at that time would be 0 also. Does that make sense? Okay, so that's the first part of the question. Second part of the question, it's also good for y'all to see this early on, because this is something that they expect you to do occasionally. It's not something that you can do often. But even on your AP exam, sometimes they give you functions and ask you for the derivative and it's something that you literally cannot do by hand. They expect you to do it in your calculator. So this is good for us to practice with because, I mean, it's a good way to check your answers, and it helps remind you that this is a possibility. So if you hit alpha window on your calculator, now if you have a TI-83, those don't have this menu. And if you have a TI-84 that's a little bit older and you've never updated your software on it, you're not going to have this menu. But you can always borrow my calculators. These options 3 and 4 are two that we use quite a bit in calculus. This one is for integration, which will be important next semester, but option 3 is for derivative or derive. So if you select that, you can say, tell me what the derivative is in terms of x of, our function was -2 cosine t plus 5. Now notice I put x's instead of t's. If you want to type t's there, you can. You just need to be consistent. So you can make this a t and this a t, and it's the same thing. Your calculator is not strong enough, and it's purposeful. They don't want you to be able to do this on the AP exam. It's not strong enough to tell you what the derivative is. It will tell you the derivative at a specific point though. So if I want to know the derivative when x equals pi, you plug that in, hit enter, and it can do that for you. So it confirms 0 is the slope of that equation at that time. Okay, so again, to find the menu, you got to hit alpha window, and then it should be option 3. It's in some other menu as well, and I guess it would be in the catalog as well. But so let's look at one more like that. We might as well. That was 36. Okay, so nobody asked about 33, but we can do the calculator part of 33 together. So, know where to ask your calculator how to take a derivative. In 33, you were finding the derivative of this when x was 1. So, again, two things here. You absolutely have to do this by hand. Calculator is not needed, but it's good for you to practice with the calculator so that you remember it can do that when you need it. And 2, calculator can't do a derivative. It can only do the derivative at a specific point. It can't give you the whole formula. And you have to be aware that the way your calculator works is sometimes it has a tiny, tiny, tiny bit of rounding error. So on question number 33, did you get an answer of 8? Yes? Well, notice the calculator said it was 8.00000008. It just had a tiny bit of, bless you, had a tiny bit of rounding error. It's trying to say 8. So it's just the way it computes it. Okay, is there maybe one or two more I can work for you?
U42.
Sure. So 42 looks like this. Now, to be honest with you, in a couple classes you will know something called the quotient rule. Quotient just means divide. So when you have something divided by something, I can give you a formula. To use that formula, you have to be able to do power rule, but you can do the product rule at that time. Honestly though, this is probably still easier. Using fraction stuff, you can split this up. You can't split apart denominators, but you can split apart numerators. I can put 2x to the 4th over x to the 3rd minus, I can put x over x to the 3rd. So simplify your fraction if you can. And the point of doing that is it makes this derivative easy, and then that derivative's not too bad. Just power rule and move the exponent so it's a positive exponent, and that's all it asks for. So that's what the answer should look like. Again, one of the book pages y'all picked up is the odd answers in the back of the book. So I know this is an even question, but is that okay? Always, always, always. If you can do exponent work, fraction work, simplify any algebra before the calculus, you probably want to do that. Okay, if you would take a couple more minutes and just keep going, please. And then I will tell you how you can get help to finish that up outside of class, and I will share today's puzzle with you. But right now you still got 15 minutes. So. I'm going to pass a stapler around. I'd like for you guys to staple the book pages together. So each have the solutions on the back. Staple those, please, and then just pass it down. And I'll come around and collect those in a minute. Again, you do not keep the book pages. The book pages are on my website. Okay, now that we're down to about 10 minutes here, let me let you know what you need to do. And I'll share the puzzle with you today, and then you can go back to work and if you want to. Okay, so I did change my mind based on how quick those questions are, so I do want you to finish up assignment 17. So you guys should have 5 to 10 questions to do for homework. I do not plan on taking any questions from this next class. And the reason is, not because I don't think that you might not have a question or two, but on our class website that you go to everything else for, if you scroll down to assignment 17, here's the full assignment. Here you can check the odd solutions. I guess I do need to attach the book assignment on there, I'm sorry. But then every one of these questions have been worked out individually. So if you do the assignment and 57 is the only one you struggled with, click 57. And it'll be a video of going over that one question, 3-minute video. So you need to use those with any questions that you need help with. So that's the plan. I will only see you one more time this week. Friday will be a B day for the first time this year. So on Wednesday you need to have those finished and ready to hand in. So any questions about that? Okay, then for the puzzle, I think I showed you. Did y'all do this one yet? Okay, then that would be your puzzle for today, just something different. So feel free to keep working on your homework until the end of class. Again, you still got about 10 minutes.
Oh wait, no, I'm lying. Hold on.
And the book pages, so that I have these for you next time. Again, I need these back. I can't make whatever 6 copies times every calculus student I have. So right here at the front of the table, this box, please give me your book pages back. You can either do that on your way out or as you find a good stopping place for your homework.
No, I did not do the same thing. I'm just gonna look at the solutions when I get home, you know? I'll fix it then.
Well, it's not that it's a code, really. It's just that if you can do it.
Yeah, I don't know what 7 stands for.
I think it's repeats. I think it might always repeat. That's what's important. It's not supposed to be a code.
So I think we can just keep our rule there.
It is, but I don't know.
I keep getting every time there's a 0 with 7 here.
I already read it.
derivative of constant equals 0. That's why you think that's why oh, okay, because you want to know when it's horizontal line, that's when the derivative. So now you can just like this equals 0 and follow
I did.
on the bottom and the top of the negative.
What? Yeah, that's what happens to those on after my school.
Whenever you move it, changes the
We get.
Negative 1/3 in the numerator.
You're a bit too dark for my liking, so big.
I was bored.
Yeah, that was it was.
Any quick math I can help with?
I mean, the last lesson only so.
How are you going from stealing stapler to stapling fingers to stapling eyes? Like, I can get the fingers, the eye, I can't go. It's just such a pretty much the only thing I can do. Some days, I really do worry
You could?
When you were a child, they take away your life.
I thought it was 17.
You run over here. See, I wasn't allowed to crawl around the living room after I pulled my cat's tail. My brother wasn't allowed to get on the high school after he kept pushing us over and falling over. I mean, I wasn't on top, but
We walked in and we were like, I must have been really understanding. Now we do loopholes now. The way I explain my stuff is so out of the way. It's like 10 different grades. What do you think Tony got?